tonight to do what universities and colleges all over the country often do, which is to identify a person of distinction and invite that person to come in and share his or her wisdom and expertise with the university community. But tonight is different. We have not just a person of distinction, but we have someone whose influence spans the stratosphere, basically. He has influence in academia, in industry. He has influence with the federal government, with international communities and enterprises. So we're truly fortunate. It's an honor to have Dr. Nasr with us this evening. But first, I must tell you a little bit about him and what he has done. He is the founding director. He's also an associate provost at RIT. He's the founding director of the Golisano Institute for Sustainability at Rochester Institute of Technology. He also serves as the CEO of REMADE Institute, which is a national coalition working on new clean energy initiatives. His research interests include remanufacturing, circular economy, cleaner production, and life cycle engineering. He is also the founder of the Center for Remanufacturing and Resource Recovery, a leading resource of applied research in remanufacturing technologies. He is a member of the International Resource Panel of the United Nations Environment Program. He previously served as an expert delegate with the U.S. government in international forums such as the Asia-Pacific Economic Cooperation, commonly known as APEC, the World Trade Organization, WTO, and Organization for Economic Cooperation and Development, OECD. He also served on the National Academy's National Research Council, National Materials and Manufacturing Board. Dr. Nasr holds an MS and PhD in Industrial and Systems Engineering from Rutgers University. He's been featured in mainstream news media, including CNN, where he discussed issues much to do with sustainability and energy and so on. So for us as a university, this is a real treat. You know that your university is a good university when you develop the capacity to attract a person of this caliber. So for South Florida, I'm going to employ all of you to join me and give a South Florida welcome to Dr. Nasr.
Wow, thank you so much for this introduction, and I think I should stop here. So it's a pleasure to be here. I've been to Miami many times. This is the first time actually to be here at the university, and I'm really delighted. There's so much energy, and I met so many wonderful people here. So for the students who are here, and actually for the faculty who work here, I think this is a wonderful place. And I actually, every month, I'm in a different university, and I give guest lectures around the world, and I can tell you, when I say this is a great place, it really is from the heart. A lot of great things going on here. So I'm honored to have the opportunity to be here and speak to you today. I'll talk about a topic that is near and dear to my heart, where I spent many years working on this area. And I was debating as I was preparing for this lecture here of what should I cover. I'm a techie, I'm an engineer, and I love to talk about the modeling, the work that we do from a technology perspective. But I thought maybe it is really much better to actually talk about also the philosophical framework that is changing the horizon where we work and some of the insights that impacting that. So you will see some of that here. So as this is, by the way, this is my home. I spent a lot more time here than my actual home. And this building actually, it's you know, unlike Miami, the grounds don't look like that. Most of the time is white, and you probably can figure out why. We get a lot of snow there. But this basically, there's a story about this for the faculty here that would relate to that. So there was a vision to establish an institute in sustainability that offered degrees that extend our research work that I've been working on for many years at the university. So I presented the vision to the president, our board of trustees. I got great support, but they told me I have zero money to actually from the university to support that vision. So I had to go out and raise money for it. So it's my pride and joy that I actually worked very hard to make this vision actually a reality. So I will tell you a little bit about where I came from, just 2 slides, just to give you an idea about my organization. And we have a long history in the topic of our discussion here, and then I'll tell you a little bit about how the world is changing, the way we look at manufacturing and we look at the future of manufacturing. And hopefully that entices a lot of you to think of the ones that are looking for research topics to actually come up with ideas for your own research. As was mentioned, I also serve in an intergovernmental panel under the United Nations Environment Program for the last several years, and I just led a big project under that panel on the circular economy and how the global perspective for manufacturing around the globe look. So we'll give you a little bit of highlights of that work. I'm using some slides actually that were used last week at the World Economic Forum in Switzerland. A copy of the entire report is on the website in case anybody have some free time and like to read the 270 pages full of statistics and information. You can download it for free. And then I'll tell you about the latest adventure of the work that I've been doing here, creating the REMADE Institute. I'll tell you about the future of the work that we see as a nation important for to help the manufacturing sector in the U.S. and our competitiveness. So first, tell you a little bit about our institute. So the Golisano Institute for Sustainability was established to expand our horizon in this area. So we have been doing research in this area for many years. And we decided that it's time to actually also offer degrees at the PhD level and the master level, and we're introducing a Bachelor of Architecture program shortly in a year and a half or so. And involved in a lot of research, and we have a lot of international collaboration. So our focus is on sustainable mobility, sustainable production, sustainable manufacturing, and we also do a lot of work that focus on remanufacturing and resource recovery. So you will see some of that in the next slide, which is my last slide here about our organization at Rochester Institute of Technology. So we have centers. Those centers are basically applied research centers that have full-time staff, but then also collaborate with the faculty and students who actually do research at those centers. So you can see here from pollution prevention to sustainable mobility to sustainable energy systems. So they're very focused work that's done in each one of the centers. Developed over many years, and we have very healthy research budget for all of those organizations. So we have the first building that you'd see here on the left was established in 1992, 170,000 square foot facility. It's just mainly a research facility. And my latest addition that was started in 2007, actually the project started in 2007. We moved to the building in 2013. That's 90,000 square foot facility. So now, the main topic that we're talking about here, and I hope you really get the essence of what I'm going to try to tell you here and talk about here. So from the perspective, the panel I serve on is really very much focused On resource efficiency, we look at it at the global level, with half the resources that we consume in manufacturing, for example, are non-renewable resources and all of that. And our goal is not to stop the development, to stop the activities that are happening to help enhance the standard of life for a lot of people around the globe. It's really trying to do that in a way that allow us not to cause any harm or not to degrade the resource capacity that we have. So we look at that in a very serious fashion. And you can see here the list of things that we have to worry about. So these are constraints. At the beginning of the Industrial Revolution, we didn't really have to worry much about these constraints. And a lot of our system that is developed over the years, and a lot of our design approaches that develop over the years, didn't really take into account a lot of those as constraints. Now we have to think about that. Now we have to embed that into our approaches, our design, our methodologies that we use. So, so you can see here from the air pollution to climate change to the biodiversity to the resource depletion. A lot of those issues now have to be taken into account as we think of expanding our ability to provide more and more for the growing population. One of the things that you have to think about, and again, I learned a lot about how you look at things at that macro level, that system level, the global level, through my work over the years with the government and through the work that I have, that I'm involved in with the panel right now. So one of the challenges that we have is that only 2% population growth is expected from the industrialized countries, Europe, the US, Canada, and so on. 98% of population growth going forward is really likely to be, or most likely to be, in less developed countries. And typically those countries are not able to deal with pollution, with emissions, with industrialization in as effective way as we do in more industrialized countries. So that compounded factor here is of great concern to people who work in this area. So we need to be very careful of how we actually help. Also, it's a responsibility that we all have, because the impact, it's one Earth, and the impact will be felt everywhere around the globe. For example, if we have practices that are less than ideal. So there was an article, I believe, one of those mainstream magazines, I can't remember if it was Business Week or something like that, saying that China and India alone can either destroy the world or save the world. If they will destroy the world if they copy the practices that we have in the West in developing their own industrial infrastructure. They will save the world if they do it in a much more efficient and optimized and not copying our mistakes. That is really, it was a wonderful article talking about this issue. One of the things also that we were seeing is that we got 3 billion people will be added in the next 20 years as serious consumers. I mean, you can see in China the rise of the middle class, just fascinating in terms of the numbers of the growth and how GDP is growing significantly. All of that just add a lot of complexity. If you work in the engineering field, we all have responsibility to make sure our work relate to a lot of those challenges, and we are contributing to solving some of these problems. This is actually a picture, and I'm not really a photographer by any means. This is a picture with my iPhone outside of my hotel room in one of my favorite cities in the world. I'm not going to tell you which one. And this is what happened actually because of the too much industrial development in that city. The following day, I was there for the weekend. The following day, where factories were closed, I took the same picture from the same window, and you can see the difference. And this is just to give you an idea about how much, the impact of decision we make in design, decision we make in manufacturing can impact actually, people's lives, and many other factors as well. So now my panel is a resource efficiency panel. So we take a look at resource efficiency and we monitor things and we look at the outlook. as we go forward. And it's amazing that a lot of these issues are not really well understood or talked about. We seem to focus heavily on climate change. We actually, a lot of what happened in the industrial world are major factors that impact climate change, but we are kind of the roots for some of the challenges that we see in this area. So in this graph here, and this is also one of the results of the reports of my panel, you can see GDP, that black line is moving up. So meaning that we're actually doing well at the global level in terms of increasing our standard of living, in terms of increasing our GDP. And then, but you can see here the growth also in material consumption. You know, given the fact, as I said before, that there is significant challenges with material that are non-renewable, and the consumption rate is rising to a point of major concern to impact basically pricing and impact the commodity level that we have to deal with. So there are definitely a lot of challenges here. And again, unfortunately, not a lot of discussion over that. So you can see also some of the statistics. The global extraction of materials grew from 22 billion tons in 1970 to 70 in 2010. And one of the things about, you know, for example, I can give you an example of cement. The entire volume of cement that was used in the US in the 19th century, which was significant period of significant growth in buildings and infrastructure in the US, China will exceed that in 3 years. China will exceed that the entire century of consumption in this just single product in 3 years, which give you the scale of the challenges that we're dealing with. One of the things that even when we copy some of the best practices that we actually achieved in the US, when you copy it in a much, much higher scale, we typically don't really understand the implications sometimes of what will happen, even though we think in the scale that we did it before was okay, but when you scale it up tremendously, you end up with different problems, and that's what we're discovering as well. So, so I'm not an alarmist by any means, but I'm just showing you the challenges that we're dealing with and the importance of actually for all of us to start looking for clever innovation that addresses problems. So that's where sustainable production, as typically the European will refer to it, and the US here we always talk about sustainable manufacturing, but in reality, basically, we're talking about just the economical creation of goods and services using technologies and processes that are non-polluting, conserve energy and natural resources. So this is a definition that was adopted from the U.S. Government, where we had a working group on sustainable manufacturing in the previous administration. And in reality, I think what we're calling for as we change our practices, as we start looking into innovation, is we call that, the panel I serve on, we call that decoupling. So it's about decoupling economic growth from an environmental degradation. So we're saying that we need to figure out how to do things differently, and we need to rethink everything in the industrial enterprise just to make sure we address these challenges. So I hope I am making my message clear here. This is like, it's a challenge, but it's an opportunity. This is like as an engineer, I always read about Edison and Eastman Kodak and all those great inventors and how much opportunity those guys have. You know, they would come up with a new material and new process and new invention every other day. This is kind of Edison days for me, like that we all have these great opportunities. So it's, it is an opportunity for innovation. It's an opportunity to change a model and question a lot of our methodologies. So I'll give you an example, and for full disclosure, I'm the Caterpillar professor. So I am very close to Caterpillar. My work was in for many years, and this is an example from Caterpillar. So all of that, it doesn't mean that we stop making things, or it's how we actually make things in a much more efficient way. So this example here, we talk about 60% fewer moving parts in the electric drivetrain. 60%. That is significant in terms of the material consumption that we have in this drivetrain. We're making the quality of life for somebody who's operating this equipment much better. We're ensuring the reliability of the equipment is very high, so this equipment would last longer, so I don't need to replace it faster. Increasing reliability and durability of the equipment achieve the goals that what we're trying to do. So it's innovation, it is creative thinking, and as I tell everybody that I think of sustainability as the ultimate form of integration of a lot of this, the functional design and all the things that we need to design the product for, but also to make sure that we've taken into account the efficiencies, the material consumption, the waste generation, all of that as we make this product. So several years ago, I was working with an organization called OECD, which is Organization for Economic Development and Cooperation, which is a think tank for the industrialized country, established after the war, and we actually did a study at the time, and this is from this study, from the OECD study. And again, we were looking philosophically, a lot of organizations, a lot of companies actually are typically at the pollution control area. And a lot of states have pollution control, pollution prevention organization within the state, so they are in the pollution control domain. We grow from there to start thinking about cleaner production. Production that actually do what we need to do, but in a much more efficient and cleaner way. And then we start thinking about eco-efficiency, life cycle thinking, to incorporate all the life cycle consideration into the product design, and ultimately we look into closed loop systems, which we basically have total accountability for the product throughout its life cycle phases and bring the material back so we can actually recycle it properly or reuse component. So that's ultimately what we're trying to achieve. For industry to actually think this way, for industry to have total accountability for material and product is a huge change of culture. No longer I'm just interested in passing that warranty period and that's it. You need to think, you need to change your approaches. Several years ago, I believe in 2012, Ellen MacArthur Foundation, an organization established in the UK, they wanted to see how they can advance the world in this area and how they can contribute. So I was lucky enough to be one of the experts that actually I worked with McKinsey at the time. We developed this book that you can find it on the web on the circular economy. So since then, they have been the best organization in the world promoting that circular economy. Circular economy is really talking about that closed loop system. So there's a bio side and agriculture and all of that. Don't have time to talk about that, but we're talking about the blue side, where we're actually looking at ways to bring product back, recycle the material, recover material. So all of that increased consumption can be controlled. And then once companies actually have that responsibility for the product from cradle to cradle, you tend to do things differently. You tend to calculate things from an entire life cycle perspective. So it's been a wonderful period of time with the foundation actually, specifically in Europe, doing a lot of good work to promote the circular economy. So it is, if you go to the EU, they have a circular economy package, Horizon 2020, and many others. Japan, China, Brazil, many countries now adopting that circular economy principles. And we're still finding our way to endorse it here in the US. So one of the things that we talk about when you bring the product back is that the economic way is to remanufacture, is to introduce remanufacturing. Remanufacturing is actually has been in the US. US is the largest country in the world in remanufacturing. We have like close to 60, 80 billion a year worth of annual sales of product in this area. And it's a wonderful process where we do that with jet engine, we do that with automotive components, we do that with copiers, we do that with a lot of product, but unfortunately not a lot of people know about it. And in reality, I think what's happening is that we're making components that have a long life cycle. They're far more durable and can last for a long time. But the life cycle of the product itself is much shorter because we continue to obsolete things because of all the advancement and everything else we make. So now we got components that can last 4 or 5 times longer than the life of the product itself. So we take this product, we disassemble them to the component level, we restore anything that need to be restored or repaired, and we replace anything that's worn or not working, and we make a new product of some new and some reman component. So remanufacturing is getting to be a buzzword now in many countries because it's the key to the circular economy implementation. That's done in many sectors, from IT product to heavy duty to copiers and so on. Medical devices, a lot of that. However, there are significant challenges. So, as I said before, I'm a techie, I'm an engineer, and I just wanted to give you examples of the kind of innovation that we can work on that I think universities are typically is a place where we launch innovation, we help society addressing many of the challenges that we face. So I just inserted a few slides here. I don't have any equations in the slides, which is something I love to do. I talk about all the specific algorithms that we work on, all of this stuff, but with the presentation time I have here, I didn't want to do that. But the key here is one of the things that that is so critical for us to achieve our goals is that connected system, is that smart system. Those systems have become far more efficient. Those systems far less consuming than actually otherwise. The system that when you monitor equipment and equipment health in real time and you're able to optimize the condition, then you're able to have equipment last longer. You're able to optimize the condition so you have less consumption of fuel. So this area is going to explode with tons of innovation. The IoT in the transportation area is already on its way, and there is going to be a lot more work in this area. There is a lot of algorithm to be developed, how you make these devices. And I said I'm just using transportation as one example here. How do you actually monitor the health of your equipment? How do you monitor any degradation? What happens when you actually something degrade in a piece of equipment and you wait until it breaks something else, and it's like chain reaction. If you're able to stop it before the break point, you're actually able to save a lot of money and a lot of repair costs by doing that. So that early detection of equipment, we're very lucky that we had, over many years, we had contract with the U.S. government in the military side, and we've done tons of work in this area. And a lot of it is, again, looking into the embedded algorithm, the technology to monitor the system health, and then the decision algorithm that is used to actually provide real-time feedback to the control system so you can optimize the condition and you can actually ensure that the equipment uptime is much higher than otherwise. So this is kind of, just an example that the technology, it's innovation that would allow us to turn things around. So this is my second topic now, is talking about the circular economy and the project that I mentioned earlier that I led was UNIP IRP, the International Resource Panel. This was presented last week in Davos at the World Economic Forum. So the key here is that we wanted to see all the different processes, how it's done around the globe, how we can measure it. So, and that was the goal of this study. They mentioned earlier our panel, the focus on resource efficiency, the IPCC, which is the Intergovernmental Panel on Climate Change, deal with climate change. There's a biodiversity panel. But this panel basically is a panel that consists of 40 of the top experts in the world, and when we have the government representative from all different countries. So the work is done in really a wonderful way because it's done scientifically and it's done to guide policy. So all of our work is intended to guide policy around the globe. So you saw this Ellen MacArthur Foundation butterfly chart before. The circular economy, and a lot of data here is European because we don't really have much going on in the US or measurements in the US. So you can see here, we're saying that resource productivity can be up 3% annually in Europe if that's implemented, 6.6 trillion per year by 2030. It can reduce the EU emission from materials by 56%, and it can reduce decarbonization costs of heavy industry significantly. So it shows basically a lot of the studies and a lot of analysis that go into the circular economy model has significant impact and significant economic value to many countries. So I'm going to skip this one here because it's to make sure I have time for the other slides. But this here is an eye chart here for you. And basically what you see in front of you is that we're trying to model the material flow for a product or production. And for the first time, we're incorporating that circular economy consideration here. So we need to have material to make products. So we're looking into the virgin material. We're looking into the imported core. Core is the old product coming back. So we're using this material. Some of it would be reusing components. Some of it will be recycled. And then we're looking into domestic cores. And we're looking into recycled material content. So for the first time, we're trying to model that based on all material flows that we would have, not just the virgin material as we always did before. So this is kind of the essence of the study. And I got another eye chart here for you. So we looked into what the kind of barriers we have for implementation of the circular economy. And what you really care about is a recovery barrier, our ability to bring materials back, to technical barrier, to market barriers when you have a product that is actually available now that we remanufactured it. Sometimes the consumer don't see it as equal, so you end up with barriers in this area. And then regulatory barriers, which is significant. Many countries around the globe have actually restrictions on the sale or the development of these products. So, for example, if you have an iPhone and it's no longer working, or you basically stop using it, now it's hazardous waste. It's considered hazardous waste. So you can't ship it from one place to another anymore because now it's considered waste. And the European Union actually has a lot of definition of waste and what's considered hazardous waste. You got heavy metals in it, you got a lot of stuff, so that's considered hazardous waste. So if you're sending it somewhere for remanufacture or reuse, you'll have significant restrictions because of that. So some of the study showed basically that we actually did the study in the US, Germany, Brazil, and China. And we had a lot of data collection and workshops in each one of those countries. And we discovered in this area the ability for us to get an iPhone back to a facility where we can put it into reuse or used components or anything like that is hindered tremendously in countries like China and Brazil, for example. So there are a lot of regulatory barriers. There are technical barriers, there's market barriers, and recovery barriers. And you can see here from the color coding, when it's red or orange means that it is a challenge and there are significant restrictions. So, when you actually, at the global level, we make product that's sold everywhere. When you actually block that flow, you're really impacting the entire population, the entire product, because the economics will not work. And that's why the study was so important for the policymakers, because it shows basically that we have significant barrier to recover material, to recycle material, to reuse material, to remanufacture product. And that's, so we're doing a launch of the reports in different regions. A region can be North America, for example. And we're trying to, we have a lot of discussion with policymakers in different regions around the world, trying to learn more about how they see implementation of this. So here's some of the example. This is a material impact per unit This is a case study from industrial digital printers, a large printer, $500,000 each, for example. You can see some of the biggest consumption factor in this new, the OEM is the original manufacturer here. This is from a material impact. The biggest impact comes from the raw material that we use to make this product. You can see here the production waste associated with that also is that darker blue. Remanufacturing, comparatively speaking, to make one of those machines, remanufacture one of those, have significantly lower material consumption because we reuse a lot of components, and then also have far less waste. That's why it's so attractive to policymakers, because we can remanufacture some of those machines 5, 6 times. And the reality is, a lot of those machines become really obsolete 5 years later, before the frame and all of those very valuable components actually become degraded. So, and that's really what the new frontier for us is all about. If you take a look, we did also scenario analysis. We looked into a country like Brazil, for example, and this is the status quo here. And you can see this is the material avoided by doing remanufacturing, for example, and the energy avoided as well. You can see this is the status quo. If I'm able to have a standard open market, like comparing them to the US processes today, you can see the difference. And the third model I call the theoretical high. So if we eliminated all the barriers, so just think about one country, about their consumption of one product. Imagine if this is implemented across the board. You know, there's significant value in implementing those circular processes in this economy. So as I said before, the panel is a policy panel, policy advisory panel. So our job is to do scientific study, unbiased, independent, clearly. It takes like a year and a half to do the peer review, and it's significant. And the peer reviewers come from all over the world. The most painful ones were from European countries where they actually picked on every, the comma in the wrong place, which they were wrong, and a lot of wording and stuff like that. But anyway, you have to deal with all of that. So this here is just showing you some of the challenges that we have related to, from a policy perspective, we're looking from an industry side, what industry need to do, and what's also needed from the government side. And a lot of these were from ease of disassembly, for example, so you can separate materials, separate components, so you can actually recover those to increase the consumer acceptance of product. And government in some countries represent 20% of the consumption, big governments. And if they become like more of a model to use some of this product, they help open the market to develop standard and processes for something like that. We still don't teach about these processes like remanufacturing, for example, in engineering schools today. Now, my last topic, and again, I'm sorry that I'm trying to pack too much here to share with you. I want to talk about the REMADE Institute. So the U.S. government decided that they finally, and I know I'm recorded here, so I be careful. I don't work for government, but I'm ad hoc government in my role at the REMADE Institute. So the U.S. government actually finally, I think, realized that manufacturing is so important to the U.S. economy, to our standard of living, continue to have the standard of living that we enjoy, to the economic prosperity of the country and economic security of the country. So finally, manufacturing became a good word to actually mention in Washington, not a bad word as it used to be. So the recommendation came from the PCAS, the President Council Advisor in Science and Technology, that the U.S. need to do something to ensure our competitiveness and ensure that our industry is gonna do well. So they basically came up with a recommendation to develop national institutes that will take the lead in advancing the U.S. competitiveness and knowledge in different areas. So I was lucky enough to be involved in a lot of these processes. I was actually at the time at the National Research Council Board on Manufacturing, and we tried to provide also some opinions related to this. So there was a process that took a while, and they ended up recommending 15 institutes, and they ended up funding 14 of them, and one is in competition today. So this is a whole list here. You can find that on the website of all the institutes that exist, from lightweight material to composites to digital manufacturing to the REMADE Institute. And that's the REMADE Institute that I worked very hard with many of my colleagues to actually to start, which was a huge thing. I mean, to have something that focused on recycling and circular economy and remanufacturing and redesign to be on the list was a big deal. The green here are all the states represented in all of those institutes. The REMADE Institute is focused on advancing the nations in the sustainable manufacturing area. And if you just look at the second paragraph, we're focusing our effort on addressing knowledge gaps that will eliminate and or mitigate the technical and economic barriers that prevent greater material recycling, recovery, and remanufacturing and reuse. So one of the things that it was written actually in the RFP that probably 50% of the volume of material that end up going to our factories to make product end up in one form or another in the waste stream within a year. Meaning that we generate a lot of waste in our manufacturing process. Sometimes this material is cheap because the scarcity of this material is not reflected in the price. So there's a lot of energy embedded and a lot of emission embedded in those material that we actually went to the factories. And if we can do better in reducing that volume of waste, we can do very well in terms of reducing our emission, reducing our cost, and reducing the waste. So the institute is divided into 5 different nodes. And from the system analysis, where we do all the system thinking, we monitor data nationally, we look into all the information at the national level. We have a design node. We're looking into what needs to happen at the design level and how do we actually think of different approaches and how we promote different technology in design. We're looking at manufacturing material optimization. How do we reduce the waste in manufacturing? How do we incorporate recycled material in making of new product? How do we eliminate the gaps? And looking at remanufacturing and end-of-life reuse. How we increase the volume of what we do in remanufacturing. And then the last node is recycling. And recycling here focus on 4 classes of materials to start. Those classes are at the bottom, as you can see here. So that's a starting point for us. And I'm just gonna go a little bit fast over this here, but the goal here again is that we're using, this is the first effort anywhere in the world to actually look at the problem at the system level. So we're looking from design to all the different processes, the recycling processes, the remanufacturing, reuse, to the material optimization, all under one roof and under one organization. And that has significant impact on our ability to really make a difference. We monitor national data. One of my colleagues at REMADE got really creative in describing basically our ecosystem, and he took it literally here, describing all the different factors that we deal with, you know, from the supply chain issue to other, and really we are focused on the technology. So technology is our main focus. So our mission is to eliminate, mitigate the technical and economic barriers. Our goal, as you can see at the bottom here, typically a lot of times research is done, papers are published, reports are made, and then it sits there. Bridging that gap is always a tough thing to do. Making sure that the work finds its way to implementation. Sometimes our work was not good enough, but we don't know because we haven't tried. And that's really the goal for us, is really to cross that gap and make sure the technology is implemented. There is nothing more exciting than being part of the solution to a challenge like that. So this is what kind of keeps us up at night, trying to make sure that the project that we select, the approaches that we use, are going to get us there. And again, as I said, this is like Edison days, again, all over again, because we are working on questioning a lot of the different processes that we use and approaches that we use. So the government actually set like very, very aggressive goals for us, from 30% reduction in primary feedstock, all the different materials that we use in manufacturing, 30% reduction in the primary one, the virgin material, 25% reduction in embodied energy of targeted materials. We want to also enhance the processes so we can use less energy in these processes. 30% improvement in energy efficiency of secondary material processing. So, aluminum, virgin aluminum probably use extremely much higher energy than recycled aluminum. Maybe recycled aluminum use 20% of what's used for the virgin aluminum. That's huge, but we're also trying to reduce that more. And then what we're trying to do also to make sure that the cost parity, meaning that we want to reduce we want to increase the quality of recycled material and also make sure it's comparable to new material. So this way, we don't want to make recycled material more expensive than virgin material. So I actually have two examples to show you. Example of projects that are underway, that are selected for funding, and I'll jump right to the examples. They're very hard to read because they're long, but you can read the title to give you an idea about the kind of work that we're funding. It's quite an honor to be involved with an institute that have such a national goal, and we monitor all the national data and making sure that we're making progress. There were universities that actually partnered, so the institute, I'll show you that here in a minute, the institute have so many partners, and you'll be glad to know that your university was one of the wonderful partners that's from day one. And not only that, your Dean of Engineering actually came to our meetings and participated in our meeting and brought the faculty from University of Miami and College of Engineering to participate. So you guys had a major, major part in developing this proposal, developing this institute, and continue to be involved at the institute. So you can see here one of the project assessment of the impact of single stream recycling on paper contamination for material recovery facilities. And if you have any questions about that, that's University of Miami project, and the PIs are right here. The second one is determining material, environmental, and economic efficiency of sorting and recycling mixed flexible packaging and plastic wrap. Procter & Gamble just had a challenge for, I think, 1.3 billion, I believe, to figure out, because a lot of our plastic packaging material ending up in oceans. There's more plastic in the ocean today than there is fish. So that's one of the things that we're trying to solve. And as I mentioned before, we have many, many partners, Unilever, Michelin, Nike, Caterpillar, John Deere, many great companies involved. And you can see the map here of where our members are. So we are very proud of all the members and all the partners that we have in this institute. So I know I talked a lot. I told you a lot about different things here that are happening. But I hope some of this will open your eyes a little bit to some of the opportunities that exist. And the goal is really to help get more people involved in this kind of work and engage in discussion. And you need to always question, what you're doing to see if there's a better way of doing it, because that's how innovation is the only way out of the challenges that we face. So I am going to stop here and see if anybody has questions or.
Do we have any questions? I would imagine there are quite a few. Yes.
With manufacturing, the remanufacturing, usually takes place, I'm assuming, within the same company. However, does it happen at an industrial level or within
Yeah, wonderful question. So remanufacturing in the U.S., as I said, it's almost 80 years old, but it's also brand new in other sectors. So some sectors like the automotive, agriculture equipment, it's very old. Sometimes, other sectors it's brand new, and some they don't have any. So typically there is a factory-based operation. So if you go to Peugeot, for example, in France, they make their engine in the same factory as they remanufacture the engines. So they're basically separate lines, but they make them in the same facility. There are many third-party companies that remanufacture as well. The key here is that it's a factory-based operation, and it has to follow the standard and the inspection and all the processes as you do when you build a brand new product. The upfront, basically, the disassembly, separation, and inspection and restoration, all of that is similar. Is not similar, obviously, to the new build, but the other part of the operation is very similar to what you do with a new build. It's like you're assembling a product again. Good question.
So you mentioned about one of the challenges being getting industry to kind of adopt these principles, and I was wondering what kind of methods can we use to do that, since right now the virgin material is very cheap and it will make them most profit, so why would they want to switch to something else?
Yeah, that's the challenges. That's why policymakers are very interested in this. So the challenge is the scarcity of material is not reflected in the pricing. And also the challenge also is that the waste that you generate, because the material is cheap, so the waste you generate, also the cost of disposing some of this waste is not also expensive, so why would I care? I'm focusing on something else to make more money. So that's one of the challenges. So, a company like Unilever, for example, have adopted practices that actually incorporate a lot of things to make sure that they're doing the right thing and they're doing it on their own. But how do you get the rest to also understand this? There's some theory that the pricing of a lot of commodities since 2000 has skyrocketed, that this is going to self-correct. But I think there's no guarantee, and I think it is important to figure out ways to do this. So it is one of the challenges. There definitely the economic incentives are not there if you're not driven to make sure to do the right thing.
I was wondering how would be the impact of the United Nations panel on the decision making regarding sustainability? How does that differ from the political views of each other in less developed countries or like the US and Europe?
That's a wonderful question. And so the United Nations panel, the IRP, because we deal with resource efficiency and we're not political by any means, and we're focusing on looking into bringing science to guide policy. And we have proven through my study, for example, that this is to the best interest of the countries to apply this. It's no longer no, you're dumping your waste on me. No, you do it first. It has impact on each individual country. So we did it for developed and developing countries, and it shows very clearly the impact on the individual countries if they actually apply the right technologies in this area. So there's a lot of incentive in that regard. They just basically were waiting to see evidence of how the magnitude of impact, because nothing was out there before actually this report was done. The challenges obviously is in execution. So in the EU, for example, each member nation has its own ways of implementing things. So sometimes shortcuts are made. Sometimes things are implemented correctly in different member nations. China has been very big on adopting some of this, as well as Japan. Execution can be different, I guess, in different countries. We're going to see. But in reality, it's not controversial. It's not political. And it's in the best interest of the countries to actually implement some of these challenges. And there are many initiatives on the books to move forward with implementation.
I want to ask ask you, Dr. Nasr,
Sure.
is there any body that's specifically responsible for compelling compliance when it comes to adherence to some of these well-proven methods and problems? I mean, is there anyone that can call up a country and say you need to do more? Who compels compliance?
That's a wonderful question. I mean, there are many sides to this. Like, for example, the stakeholders for this are different. I mean, there are organizations that deal with trade, for example. China, Brazil, many of the developing countries have significant barriers for trade, for example. And even you solve it, then you have problem with customs in these countries. They don't allow the used product to get into the country. I mean, I don't know how many of you heard that China lately, because of a really bad TV program showing how poor the practices were with plastic recycling take place in China. So they banned all of that plastic that was aggregated, sold to China, and they were using it effectively. So they banned that, and now the recycling industry in the U.S. is almost like, almost 75% was sold to China for money. Now they don't have a way to deal with it, so many of those guys are threatened to go out of business. So there are many organizations that actually have pieces of that. So some of it is in trade, some of it is regulatory, some of it is really up to industry as well. So it's not, and that's a challenge. It's not just one stakeholder that would actually be in charge. The environmental minister of many countries, including in the EU, for example, typically don't hold a lot of power. The people who are industry and commerce typically have the power, not the environmental minister. So if even in full agreement, they're powerless typically. So there is the challenge again. It's not just one agency and not one stakeholder. It's really across the board, and industry has a big role there as well. So so that's why it's a challenge.
Do we have any more questions from anyone? Okay, how about a round of applause? Yes.
Well, thank you all for attending. I really appreciate it. Oh, wonderful. Thank you so much. Wonderful discussion. Thank you.
A copy of the presentation, or is it?